Good morning, everyone. Today's training is going to be about how to convert azimuth. Before I get into all of that, I want to talk to you guys about the risk assessment. So we are outside. The weather's pretty cool right now, but if you don't have a water source is provided for you. In an event of an active shooter, we will head to the facility to my left, and if all comes to worst, then we will ambush and fight. Before we start this training, I want to make sure that you guys have all the equipment that is necessary, which is a pen or a pencil, preferably a pencil. If you don't have a pencil, I have a few here that I will provide to you. Notebook or just a piece of paper. Like I said, if you don't have that as well, I have a few index cards that you guys can use. A water source, like I mentioned before, since nobody's a heat casualty, we don't want anyone to become one, so water is provided here for you as well. Please make sure you have your common access card and your ID tags. For the purpose of this training, please make sure your ID tags are not around your neck, because since we're using a magnetic compass, it can not make it work the right way, and I'll get more into detail after. So please make sure if you have your ID tags, put it in one of your pockets on your lower leg of your uniform. Okay, since we're using formulas in this training, make sure you write down the formulas that I will mention. We want to make sure that we're mentally prepared for this kind of situation, meaning you don't have a calculator or cell phone. Main reason why I suggested a pencil would be preferable when you do the mathematical equations when it comes to this lesson. I don't want to get too into it yet because I don't want to confuse anyone. So here's the condition. You are a member of a squad preparing to conduct tactical movement, and you have been directed to convert azimuth. In preparation for the movement, you have been given a 1 to 50,000 military map with the declination diagram. So if you see closer to this map, this is the declination diagram that is included in this military map. Pencil, paper, magnetic azimuth, and a grid azimuth. So magnetic azimuth is provided for you, and a grid azimuth as well. This is some iteration of this task should be performed in MOP 4. During this task, you will be trained on how to convert magnetic azimuth to a grid azimuth to a magnetic azimuth, and azimuth into a back azimuth. Before I get into all that, you guys will be evaluated individually, but I want to get into some navigational terms before we begin. So, grid north is the northern direction on the map running along the north and south lines of the map. So as you can see, these are the vertical lines of the map, and those are called grid north. If you get closer, you'll see that these lines that is going vertical, it's also on your diagram at the bottom, and this straight line, it even tells you it's grid north. Here you see magnetic north, the northern pole of Earth's magnetic field. The location of magnetic north drifts changing slightly over time due to variations of the flow of molten iron in the Earth's core. It is found in the magnetic compass, but you do have your magnetic north here. Then you have your true north is measured from a soldier's position in the northern direction of the Earth's surface towards the geographic pole where longitude lines converge. If you look closely, if you can see that 1980, that means it's not just a number or a code that's on there, it's actually the year the map maker measured the GM angle, which is this here. And the amount of the angle in both degrees and mils. So here in this map, you have it as 13.5 degrees, and in mils, you have it as 240 mils. So I don't want to really get into this map too much, only because you will be using this map to do your evaluations. So you will be doing the conversions with this map, but I will be teaching you pretty much the same thing, but using the STP, which is what I spoke about earlier, the 071-COM-1016. So this is a picture that was provided. So before we do the conversions, you really need to identify whether in the declination diagram, if it is, if the GM angle is easterly or westerly. This is very important because only then you'll know what equation to use. So for this example, what does it look like to you guys? So obviously this is south and this is north. This side is west, this side is east. So if you guys take a closer look at this, you can tell that in this example, it is east. So the first lesson is gonna be magnetic azimuth to a grid azimuth. Please write this down. Magnetic azimuth to a grid azimuth. Like I mentioned before, you will be given different formulas. There's 3 different ones. So in this case, we're starting with magnetic azimuth to a grid azimuth. I just want to make it very clear. So you first need to locate the declination diagram, which we already have on this map. There you will find the GM angle, which is the lines between grid north and magnetic north. So the angle difference between grid north and magnetic north, magnetic declination changes over time and with location. Moving forward, use the mathematic formula to convert a magnetic azimuth to a grid azimuth. So because it is easterly, you will have to add the original magnetic azimuth plus the easterly GM angle. I repeat, to convert magnetic azimuth to a grid azimuth, you will need to add the original magnetic azimuth and the easterly GM angle. Okay. If the GM angle was westerly, which in this case it is not, then you would take the original magnetic azimuth, subtract the westerly GM angle to get your grid azimuth. But because of this example, I'm pretty much telling you guys what formula to use, is that the declination diagram shows you that it's easterly. All right, so moving forward, we're gonna get into grid azimuth to a magnetic azimuth. So remember, I just taught you how to do magnetic azimuth to a grid azimuth. Now we're doing grid azimuth to a magnetic azimuth. So since the GM angle is easterly, you're going to get the original grid azimuth and subtract the easterly GM angle to get your magnetic azimuth. So you're pretty much going backwards. You added prior to this. Now since you're going from grid to magnetic, you have to subtract it now. I don't know if that makes sense. So I repeat, to get your grid azimuth to a magnetic azimuth, you will need to get your GM angle, which is easterly, and get your original azimuth, right? So therefore you will get the original azimuth and subtract the easterly GM angle to get your magnetic azimuth. The next one, the last conversion, is convert an azimuth into back azimuth. I repeat, convert an azimuth into a back azimuth. While converting an azimuth into a back azimuth, extreme care should be exercised. When adding or subtracting the 180 degrees, a simple mathematical mistake of 1 degree could be disastrous in the field. So this is very important. So here you would need to use the magnetic compass here. So to convert a back azimuth in degrees, if the magnetic azimuth is in between 0 to 179 degrees, add 180 degrees. I repeat, if the magnetic azimuth is between 0 and 179 degrees, add 180 degrees to get the back azimuth. If the magnetic azimuth is between 180 degrees and 360 degrees, subtract 180 degrees. Like I mentioned before, you guys will be evaluated individually, meaning this is not a group exercise. So you guys are more than welcome to use the equipment that is provided to you. I will be giving you guys 10 minutes to do the conversions based off the declination diagram provided in this map. If you guys have any questions, the questions will be asked after the exercise. On your pieces of paper, make sure that you name the conversions that you're doing while you're using those mathematical formulas. So if you're doing magnetic azimuth to a grid azimuth, make sure you name it as such and do the formula at the bottom. That way I know how to evaluate you guys and making sure that you guys know the difference between those three conversions. Please make sure your names are also at the top and your rank. At the end of this lesson, I will evaluate you guys individually and tell you if you're a go or a no-go. Please begin. So I'm happy to say that everyone was a go. Therefore, our task proficiency was a tango. Now I would like to collect all the equipment that you use that belong to me, which include the pencils, the grid azimuth and magnetic azimuth, and thank you for giving me back my map. After that, we will conduct an AAR. So, first question is, what was supposed to happen? What actually happened? What went right? Okay. What went wrong? How can I improve my training for next time? Okay. So please make sure you guys clean up after yourselves. Don't leave any trash. Like I mentioned before, we are a green army, so please pick up after your water bottles, any trash, any pieces of paper. Leave the place better than how you found it. Sergeant First Class Hardy, Staff Sergeant Lozano. I have concluded my training. Everyone was a go, therefore our task proficiency was a tango, and I have released my soldiers. Thank you.